In this video, we're going to try and solve the fourth question of assignment number 14 related to the median. I'm solving and uploading this answer first as at least three of the students from your class have asked this as a doubt. So as you can see, the difference here between the earlier questions is that the classes, rather than being specified as 10 to 20, 20 to 30 and so on, they have been specified as less than 10, less than 20, less than 30 and so on. So how do you read this data? Well, you will read it as, if I take the green pen just to show you, you will read this entry as 35 observations are less than 30. Similarly, number of observations less than 50 are 62. The number of observations less than the value 60 are 77. So what this means is the total number of observations is 77. So I hope you have recognized this as the cumulative frequency, because it is always in the case of cumulative frequency that we have classes as less than 10, less than 20 or so on. Or in the other case, you can have more than 10, more than 20 and so on. So every time you have classes specified in this manner as less than or greater than, remember that the frequency that is being shown is the cumulative frequency. You can also notice that 4, 20, 35, 55, the numbers are continuously increasing, which also gives you a clue that this is the cumulative frequency. So now that we know it's the cumulative frequency, the first thing that will be helpful to us is to convert this into the regular class intervals. As you can see that the upper limit 10, 20, 30, 40, the distance between the upper limits is uniform. Everything is at a distance of 10 units. So it is reasonable to assume that your first class interval is 0 to 10, next is 10 to 20, 20 to 30, 30 to 40, 40 to 50, and finally 50 to 60. So this is your class interval. Okay, I'm writing it INT for short. But we still need to find the frequency with respect to each class interval, 0 to 10, 10 to 20 and so on. Since there are 4 observations less than 10, you know that there will also be 4 observations between 0 to 10, right? And to get the number of observations between 10 to 20, all you need to do is, we know that there are 20 observations less than 20, and we also know that 4 of these are less than 10. So to get the number of observations between 10 to 20, just do 20 minus 4, which is 16. For the next observation, we know that 35 observations are less than 30, but 20 of these are less than 20, and we want to get the frequency corresponding to 20 to 30. So 35 minus 20 is 15. Similarly, over here, to get the number of observations lying between 30 and 40, we know that 55 observations are less than 40, but out of these, 35 observations are less than 30. So remove them. Okay. Similarly, 62 minus 55 will give you the number of observations between 40 and 50. And finally, 77 minus 62 will give you the number of observations between 50 and 60. So, using the black pen, 55 minus 35 is 20. Okay, that's equal to here. It's implied, but just in case you get confused. So, 62 minus 55, 77 minus 62, right? So 4, 16, 15, 27 and 15 are the corresponding frequencies for the class intervals 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50 and 50 to 60. Now, to find the median value, the formula is L plus n by 2 minus m divided by f into C. I hope you remember what those are. N by 2 will be 77, the total number of observations divided by 2, which is equal to 38.5. You can round it off to 39. And remember, to find the median, we anyways need the cumulative frequency column as well. Okay, so to locate the 38.5th value or the 39th value, we need the cumulative. We need to look along the cumulative frequency column. And as you can see, the 38.5th or the 39th value will lie in 30 to 40 class interval. So, okay, let me use another color. I'm using red this time. 30 is your L, or the lower limit of the median class. Median class is 30 to 40. M is the cumulative frequency till the median class. So the cumulative frequency corresponding to 20 to 30 is 35, which becomes your M. F is the frequency of the median class. In this case, it is 20. And C is your length or size of the class interval. Just do upper limit minus lower limit. So you will get, in each case, you will get 10, right? Plugging all these values into this formula, I can write it as 30 plus 38.5. Once again, in some statistics books, they do round it off to 39, but and some continue to work with the decimal place. You can do either. The answer will only differ by a few decimal points. So you will get, as long as the method is correct, you will get your full marks. So that's 38.5 or 39 minus 35 divided by F, which is 20, into C, which is 10. Which is equal to 31.75. You can round it off to 32. So that's how you will find the median. Now, depending on when you're solving this question, because the next topic that is handled in the course is the mode. The formula for mode is as follows. The next question with the same data is to calculate the mode. Now the formula for mode is given like this. It's L is the lower limit of the model class. Delta 1 is the difference between the frequency of the model class and that of the pre-model class. Similarly, delta 2 is the difference between frequency of the model class and the post-model class. So, to find the model class, look for the highest frequency. And as you can see here, it is this. So, the model class is 30 to 40. Alright, so L will be 30 plus the difference between the frequency of the model class and the pre-model class, which means difference between these two divided by 20 minus 15 plus the difference between model class, frequency of model class and post model class, which is 20 minus 7 into C, which like I said earlier is 10. So this value can be calculated as 32.7778. If you want, you can always round it off and write it as 33. So this is your mode. Now, another question that they ask is it possible to calculate the arithmetic mean? Now remember, it is tough to calculate arithmetic mean when you have open-ended data. That is, when you have less than 10, technically the lower limit of the first class is not specified. However, our observations that the space between the upper or the gap between the upper limits of all other classes, since they are constant and 10 equal to 10, we have assumed that even the first class will have only a width, class width of 10 units, which is why we have assumed it to be 0 to 10. If we make this assumption that the lower limit of the very first class is 0, then we can proceed to calculate the arithmetic mean using the frequency values that we have calculated in the last column. So you can calculate the arithmetic mean if we make the assumption that even the first class interval is of the same size as the remaining class intervals, which is 10 units. Given that assumption, it is possible to calculate the mean, and you can calculate the mean using any of the methods, shortcut, step deviation, whichever you like. Now to calculate the arithmetic mean, we first remember we need the midpoint or the midpoint we need the midpoint, which will be our x. So the midpoint can be calculated as lower limit plus upper limit divided by 2, which will give us 5, 15, 25, 35, 45 and 55 as x. Now I'm going to use the step deviation method, as that simplifies the calculation. So I'm going to take the middle value, one of the middle values, as a. So taking a to be 35. You have the freedom, you can take either 35 or 25, right? Preferably take the middle value. So, but here since we have 6 observations or 6 rows, you have to choose between the third and the fourth. So my D which will be x minus a divided by the class interval, which is 10 in this case. So 5 minus 35 by 10 is minus 3. 15 minus 35 by 10 is minus 2, minus 1, 0, 1, 2. Next step, multiply frequency with d. As you can see here, the numbers become much simpler. So 4 times minus 3 is minus 12, 16 times minus 2, minus 32, 15 times minus 1 is minus 15, 20 times 0 is 0, 7, this is 7, 7 times 1 is 7, and 15 times 2 is 30. As you can see, summation ft is a much smaller number since you have both positive and negative values and they cancel out quite a bit. So summation ft is equal to minus 22. Now summation f or total n, as we have noted before, is 77. So now the formula for arithmetic mean, I'm going to call it x bar is the assumed mean a plus summation f times d divided by n into the class interval, size of the class interval. Like I said, I had assumed 35 to be the assumed mean, to be the mean or a, plus minus 22 divided by 77 into 10, which will be equal to around 37.86. Again, I have rounded off, so a few decimal places here, points here and there, won't be a big issue. Remember, the answer to the last one is that if we make the assumption that the lower limit of the first class is 0, this is based on the observation that all the other classes seem to be of the width of 10 units. If this assumption is not true or cannot be made for any reason, then we would not be able to calculate the arithmetic mean because there is an open-ended interval. I hope it's clear. Thank you.